We're going to talk about rational numbers today. Now, rational numbers are numbers that you can write as a fraction. Okay? And most numbers we're talking about, and most numbers that we've looked at, you can write as fractions. Whole numbers, any whole number can be written as a fraction. Okay? So 5 can be written as 5 over 1. -3. So negative whole numbers can be written as fractions. -3 over 1. We just talked about fractions and mixed numbers. So any mixed number can be written as a fraction, as a top-heavy fraction. Right? You with me so far? Mm-hmm. Now, what about decimals that end? 0.5. Can you write that as a fraction?
Yeah, it would be, I'd say 5/10.
5/10, and then you can reduce it to 1/2. Yep. So that's a rational number. Any number that you can write as a fraction with a whole number over another whole number, no matter how big the number is, that's called a rational number. How about this one? 4.363, or 4 and 363 thousandths. It ends in the thousands place. Can this number be written as a fraction?
Mm-hmm.
Yeah. You could change it to a mixed number first. 4 and 363 thousandths. And then move the whole number to the top line, to the numerator. 4,363 thousandths. Or you can just do that right away. 4,363 thousandths. Okay? So that's the first part of your worksheet that you're going to be doing, is writing these numbers as fractions. Writing all these numbers as fractions. All right, do the evens of those on this page. Now, flip it over. Oh, I'm sorry, before we go on, if these are all rational numbers, that means there must be some that are irrational numbers. What are irrational numbers? Tyler?
The opposite of rational numbers.
It's the opposite of rational numbers. So numbers that you cannot write as fractions with a whole number over a whole number. Okay? Here's an example. The number for pi. 3.141596254, I think, something. And it never ends. That decimal never ends. It just goes on and on and on and on. So that's called an irrational number. If it's a decimal that never has an ending, it's non-terminating. Decimals that end are called terminating decimals. Decimals that don't end, like pi, are called irrational numbers. Okay? They're not repeating decimals. That's different. Repeating decimals you can actually write as fractions. Can you think of a repeating decimal that you can write as a fraction? Does anyone think of a repeating decimal you can write as a fraction?
Like a repeating one?
Yeah.
Like 2/4?
How about 0.22222?
Yeah.
Yeah, you can write
And
that as a
then,
fraction.
why does it go 1, 5, 3, 4, 5, 6, 7, 8, 9?
I don't know, but look up here. A repeating decimal like this can be written as 2 over 9. Okay? 0.2 repeating. If you put 2 divided by 9 in your calculator, it'll come up as this. What do you think 0.3 repeating is, or 3/10 repeating is? Becky?
3/9.
3/9.
I have a question on the worksheet.
Hold on. I'm not on the worksheet, I'm talking to you about repeating decimals. Well, 3 ninths. How can you reduce 3 ninths? Bennett? Yeah, divide them both by 3 and you get 1/3. So 3 repeating is 1/3. Okay? 4/10 repeating is 4 ninths. 5/10 repeating is 5 ninths. 6/10 repeating is 6 ninths. What's 6 ninths as a repeating, as a simplest form? 2/3. Okay? So, don't forget that repeating decimals can be written as rational numbers, as fractions. But here's an example of an irrational number. Okay? Have you ever heard of the square root of a number? The square root of a number. Okay? Tyler?
It's like dividing it by the power of 2.
Yeah, it's like dividing it by the power of 2. In other words, what times itself would equal 4? A number times itself that equals 4.
2.
2. Yep. Can you think of other, these are called then, these numbers that you can divide by themselves to equal a number are called perfect squares. Can you think of another perfect square? Square root of 9, right? Equals, what number divided by itself would equal 9? I'm sorry, times itself. A number times itself that would equal 9. Okay? 3. Yep. How about the square root of 16? And the square root of 25. These are all what? These are called perfect squares. Yep. But you can find the approximate square root of any number. Okay? It just wouldn't be a whole number. So, for example, the square root of 3, if you put that in your calculator, it's not 1.5.
Where's the square?
What is it approximately?
I know.
You need a calculator to find it approximately.
9? So I got
9? No, the square root of 3. So you got to use the second function. One point. You got it too?
1.7320508.
Yep. So it's like 1.732 something, and it goes on and on and on.
Why?
Okay? So, this, listen everyone, this is an example of an irrational number. Because you can't find the exact number you would multiply by itself to get 3. Okay? So those are called irrational numbers. Okay? Now, do you understand what rational and irrational numbers are a little bit better? Let's go to your worksheet then. So if we did the evens, you would do 4, 6, and 8. I better have you do the odds instead. Let's do the odds.
No, you would do 2, 4, 6, and 8.
There's no 2.
Yeah, because you said it was 5.
It says 5.
So?
No,
You
we're
made
not.
a typo.
How about this? How about this? How about this? I have a solution.
Okay, Matt.
Let's easily X out the 5 and put a 2. How simple is that? And then do it.
All right.
And then
You
do
can
that.
X out the 5 and put a 2.
And then do the even.
And do the evens. Now, on the back side, you have to do the evens as well. Okay? So, take a look at the back side of the worksheet. And it says on the number line,
Number 16.
find a rational number that's between two given numbers. Okay? So, number 6, how would you find a rational number between 2.3 and 2.5? On the number line. What would you have to do? So on the number line, you have 1.5 listed, and you have 2.0 listed, and you have 2.5 listed. So then you need to label these other numbers in there. Okay? Make sure you label the other tick marks on there. Make sure you label the other tick marks on there. Okay? No, I don't want you to label each one. So 2.4, 2.3, 2.2, and so on. It says use the number line to find the two given numbers. So I want you to label the number line. And then put the number, mark the number and write it down. Okay? Any questions on that section? Yes?
What do you mean by market?
Label it like this. 2.4, 2.3, 2.2, 2.1.
I did that.
Now, identify the number that's between 2.3 and 2.4 and mark it on the number line.
Yeah, right?
So put a dot on it.
There. Okay.
Put a dot. So we use dots on number lines.
So,
Okay? Any questions on that? How would you find the rational number between fractions? So, for example, number 12 says you have -3/10 and -1/3. How do you find a rational number between those two? What would go in between them? How do you know? What would you have to do? Anyone know?
you could, you could make one third go up to 4/12.
But we have tenths.
Oh!
So let's convert it to tenths.
I don't know how to do that. Oh.
So we can find an equivalent fraction. I'm sorry, change it to 30ths. So that we have the same denominators. This is -10 30ths. And if we multiply this one by 3, we would have -9 thirds. So between,
9.5.
yeah, uh-oh.
Oh, sorry.
That's right,
Nobody remembers.
except that we can't write a rational number with a decimal in the numerator. So, what can we put in between those? Well, what we have to do is we have to make the number more precise. Okay, we have to make the pieces smaller. So for example, if we changed, there we go. If we change this one by multiplying them both by 10, we'd have negative 90/300. And we'd have this one as negative 100/300. Okay?
What?
And now we can find one in between.
Are you timesing them or multiplying?
Timesing them. Yeah. So negative 95/300. Put in between them. Okay? Allison, stop talking.
Negative 9.5 over 30 times 10.
Right, multiply them times 10 again. Armand. Then copy what I did, okay? Do you have a question?
Yeah, I wasn't doing this. I was doing the other side.
All right, then you better copy what I did. Raiden?
Why did you circle 9.5?
Because negative 95 is between negative 90 and negative 100.
Oh.
Any other questions? Olivia?
I don't get number 10.
Okay. What's number 10?
Negative 30 and negative 15.
Oh, negative 10 and... So a number between negative 10 and negative 15. So think about, on a number line, this here's 0. And then, let's say we go by 5. Negative 5, negative 10, negative 15. What would be some whole numbers in between? Yeah, so like negative 12. And negative 13. And negative 14. Those are all in between these two. Okay? So you can just pick one of those. Any other questions? So do the evens on both sides then. Do the evens on both sides.